Data types. Why data types? As I first introduce um, to you guys, whatever data that you want to compute in computer, then data should be loaded. As data is loaded, because you want to compute, you have a label to hold that data. So that label is, in other words, in a proper terminology, that is called a variable. So variable holds a value. Now we have the issue. If we have similar values, like 100 such, or millions, should we declare each one different variables? For example, name Sam Smith. If there are hundreds of students' names, then should I say name 1, name 2, name 3, name 4, name 100? Would there be any other way that we can declare it efficiently, as well as retrieve it in easier way? So we need somehow data types like this. We have so many on this slide, maybe 10 values. So we want to play with those 10 values. Therefore, load those 10 values. For each value, then I need to have some labels, variables. So I may need to declare that many variables. So that is not efficient. All the programming language, I would say all. If it is not, then we don't call it programming language. As primitive data types. For example, list. Those who learned similar things in another language, you may recall array. So array may be a list. So you can hold a sequence of a series of values. Pictorially, I put there a list. So we have a number of names in one variable, and they can be in one container, bracket. So that is a list. Similarly, we have a tuple. Tuple also holds a series of data. As you can see there, John, 1, cyber, IoT. In representation in Python, those series of values can be composed by parentheses. But many other languages not necessarily differentiate that, but Python does. For example, Java, then list and tuple, those are all array. Similarly, in Swift, which is the language that you may, if you want to take one of the course that I am teaching, iPhone apps development course, which is called Mobile Technologies and Sensor Data Services, then the language that we are using is called Swift. Swift is not like Python in a way differentiating a list from tuples, all like array. But dictionary is different. So we have also a dictionary. Dictionary is a mechanism provided by Python, also possible in Swift. Java, the earlier version of Java does not have dictionary type. I've taught Java till I think 10 years ago for 15 years at the time. And also I wrote 2 books in Java, probably not available now. I'm the first generation of Java users. I started my Java programming in 1995, which is the same year that Java was first announced publicly by Sun Microsystems. Currently, it is managed by Oracle, but it was invented at Sun Microsystems. MySQL also invented by Sun Microsystems. Sun Microsystems is a really, really good company. I am still missing that company. In 1990s, I think Sun Microsystems is the best company. Like this time, maybe OpenAI or Tesla, Apple, Google, something like that. Technically, the company leads the world. I would say OpenAI or Tesla. So what is a dictionary? Dictionary is one of the data types that holds a series of data like list and tuple. But one significant difference from the other two is the way it is organized, the way it is accessed. As you can see here, if it is a list and tuple, then I put here a number, right? We call that index 0, 1, 2, 3. So we know, so the position is very, very important. John, Adam, Brown, Peter, David. If David comes next, then he is always the fifth position in that list. Yeah, unless we explicitly swap this with others. But anyway, it should be there, right? There's an index. Based on index, position is important. On the other hand, the dictionary. I wanted to recall real dictionary. Probably many of you still are very young, 20s, 30s. So when you learn the languages, I mean real spoken languages, you probably didn't use a printed dictionary booklet. Then what is the dictionary? Dictionary is to give you any explanations or annotations if you give me a word, right? Mercy, for example. Hey, what is mercy? Then that dictionary gives you the annotations, explanations, or detailed definition about mercy. That is a dictionary. So dictionary is a container holds key and value pairs. Key is like lang here, value is Python. Key is major, value is cyber. For example, what is your job? Job is a key. The value associated with this key is cyber engineer. Cyber engineer. What is a research? The key is RES. The value to this key is IoT, Internet of Things. By the way, what is a cyber engineer? Cyber engineering, cyber engineer. One of the cyber security professionals, right? Cyber security science, cyber engineering. What is the highest prestigious job title in cyber security area? That is a cyber engineering. Cyber engineering requires, I know some of you are from engineering background and also great skill sets of science. And as you complete your cybersecurity master's program, then you can pronounce yourself cybersecurity engineer. You can do not only not only science, but also engineering. Not only coding, but also manipulating devices. So coding is not simply running on your computer itself. So your programming language needs to identify what's going on in outside, like sensoring. And also, your code should do some of the actuations. It should take some action correspondingly to the situation changes. So you should know not only soft things and also hard things. And cyber engineer should do not only cybersecurity operations, but also cybersecurity developments. Probably I said that right. OpDev, operation and development. Right now, there is another thing, one more, OpSecDev, operations, cybersecurity, security, and developments. So as you, for example, as you develop, then you have to carefully consider to protect whatever whatever the target that you want to deploy, right? Not careless developments, but your deployable deliverables should be securely running. That is OPSEC dev positions. But anyway, so this is a dictionary. So we have a list, topic, and dictionary. So we'll look at how we can use that. This is another the real motivations. For name 1 equals John, name 2, we should declare 10 of those. And when we access, then we need to, one of the primitive access of name 1 is by printing it, right? I want to print name 1, print name 2, print name 3. We need to do that. But if we do, for example, this is a container called list, and I want to call it language. So language is a variable, only one variable. This variable can hold multiple or series of data. Python, R, Java, C, maybe Swift. Swift should come here, right? And in memory, once you declare that in your memory, there's a language. When you say language, then language can be evaluated in this way by accessing that containment. And then first element in that container points to the first element by index 0, by index 1, the second element, by index 2, third element, by index 3, fourth element. So we can increase more and more. We can add on top of something already existed more and more. So it dynamically increases. Also can be decreases. If we want to pop this out, then that many decreased. Or we can remove or delete some. That will be possible too. Once you have this in your memory, then how can you access? As I said, because we have an index here, if we say language within that square bracket, the index number 1, then that will point to the second element in this container, which is R. If you want to access the first element, then you need to put here 0. So lots of examples may be possible. This is, let me point out some. Yeah, you can start with the empty elements in that list. If you want to add, then we have a language called dot append. This is like a function, right? My color, this is a variable, okay? List variable. This variable has some of the good features that we can attach to it with the dot notation. So my color dot append is a function, so new element can be appended to this list where it can be appended to the last ones. For example, here if I were to append Swift, then Swift comes next to the end of the current list. So that comes here, right? That's all append. Also, if you want to access, then you can do number 1. If you want to access the range, not only each individual, but if you want to access, here I want to access from the first element to the second element. Then second element means the index 1, right? Then you should say 0:2. This is a beginning index. This is an ending index. But the value containment can be accessed from the beginning index to all the way to the ending index, but ending index itself is not included. Okay? So exclusive endings. Inclusive beginning, but exclusive endings. Then it starts from 0. Index increased by 1. So next one is 1. And 1 next to 1 is 2. But because ending index 2 itself is not included, then this will give you first element and second element only. Third element, not. So red and gold. 1 and 2, then if we say 1, this is not right? Returns, if red and gold here, then 0, 1, 2. Yeah, this is what it is. Accessed by range 1, colon 3, then it returns red and gold. 1 means there's a second element, which is red. After that is number 2, still inside of this. So that is accessed. Number 3 is the fourth element, 0, 1, 2. Fourth element is not there, right? The language that we have here. Another way that you can access by negative values. If you have a long list in that container list, then each element can be accessed by index number. If it is very long, then it's not tedious to count from 0 to whatever, right? It is tedious, but it is time killing, right? This is index 0, 1, 2, 3. You have to count. So one thing that we can make it easier is that we can count from the last. So we put negative number. So negative 1 is the last element. If we count from the beginning, then we count from 0, right? If we count from back end, because there is no negative 0. Yeah, for mathematicians, negative 0 is meaningful, but in this index mechanisms, negative 0 is not available. So 0 there. And therefore they think, oh, okay, then the end element is indexed by negative 1. We can count it from, you need to say always from a smaller value to bigger value with the colon inside. So this is the last ones, right? This is, yeah, from negative 1, negative, that way. You can see the more methods associated or defined with the list can be found from help. Okay, if you say help and type list, then you can see those. I want to bring my Paizo so that we can see it. Okay, here is the Paizo. If I do help, then it comes to me the help page, right? On this prompt statement help, then you can say list. Then you may be able to see the method or function. Sort, that is a function. Reverse, remove, pop, insert, index, extend, and append. Append, then you see the method or function items here. Then we have a function name followed by open parenthesis followed by self. They're all self there. Followed by real parameter object. So append takes object as a parameter and do append. So the explanation of this append, if you see that, then append object to the end of the list. That's what it is. There's nothing about self. Self, you may be able to see what the self means when it comes to object-oriented programming, which will be the last topic of this Python modules. When you define a method in object orientation, the object orientation can, the primitive items in object orientation is an object. It starts from object. When you want to append, then what is a self? Then whatever that we have listed before dot notation, for example, my list dot append, then my list, that is a self. So I want to append object to myself. I want to clear myself. I want to copy myself. I want to count the value from myself. That's what it is. So for now, don't worry about the self. When you look up the dictionaries, help, then if there is a function, then always self. Okay? So when you code in Python for object orientation, as you create a class, then you should say self. So don't worry about it. There's too much right now, but this is what it is right now. All right. So that's help. Remove, insert, that's all possible. So we can practice lang, for example, len, the list. If we say here, len, or len is it's not necessarily associated with the list itself, but append and count, these are associated with the list. Therefore, we say list, this is a self, dot append. Dot append, then what the literal stated before that dot notation, this is this is an object, and this is a method. This method is defined in this object. Therefore, we say object dot and method notations. Len, this is a primitive function, not like the function here append. Append is a function defined for the list, but len and max, those are the primitive function. Doesn't matter what object, but we can take it. So len takes that object itself. Max takes that object itself. The others, object dot function or method. Object dot functions. Append and extend. If you want to append an object, college, then you can, whatever the list LST points, then college can be attached to the end of that list. We need to extend with the literal. If you see here, yeah, extend is a method to itself. You can extend the literals. Extending list of appending elements from iterable. So you can append to the element. Those are literal. Literable means can be repeated. So list is a repeated, one element after another, after another, after another, like repetitive data types, right? That is a literable, which is not the case of object itself. Like college, then there's primitive data, right? College. But this is another list. So we can extend another list to the list. So we'll find out what is append and what is extend, the difference between these two. Count, that is defined solely for this list. Therefore, we have object.counts, 33. How many elements in that list? 33. So count what? Count these specific elements. If we want to delete the first if you want to delete the third element in the list, then you need to say del lst, and then this is the third one, right? Index 2. If you want to remove any specific value, then you can say lst remove 33. 33 is an element in there. We can have more. Insert, reverse, sort, pop. So how to represent a number of objects? If we have a set of objects, then we may use a list. How can we represent an object itself? In other words, to describe this object, what kinds of descriptors that you want. Therefore, we have a set of descriptors that can represent that object. What I am trying to say here, we learned the list. And also we have a tuple. They are similar, right? So many other languages provides only list like array. They don't really differentiate list from tuples. But in object, we do here. List is a container containing several values in the same type. Same kind, several same kinds data. Like John, Adam, Brown. They are same kind, right? On the other hand, tuple, it wants to describe an object, one object. In order to an object, what descriptors that we want to use. So for these specific ones, we can say what is the ID, what is the positions, what is the disciplines, what is the course, that type of things. So 1, 2, 3 is ID, positions, professor, course, discipline, cyber, course, IASP 505, something like that, right? Not many textbooks explain in this way, although that should be, right? Very nice, right? Okay, so tuple can be in this syntax, parenthesis. If we say Python, then untyped, £, indentation, self. If it is a Java, then Java is a typed language. If you want to put the comment, then Python use £, Java use //. What that means is that if anything beginning with a £, then your Python does not care. It is a comment. It is your comment. In other words, it is not evaluated. Same thing in Java, //, double slash, then don't count, right? Swift, also //. Many other languages use double slash as a comment. But £, in Python and also in Linux operating systems. If we have code block in Python, then indentation is very, very important. The position of each line is started from the left, the position 0, right? That is outer code block. One code block may contain another sub-code block. If that is a sub-code block, then entire that code block, sub-code block needs to be indented within that outer code block. Therefore, by looking at that indentation, we may see what this guy can be contained in this container, which is also contained in outer container. So it is a multiple depth of the indentations possible. Java, on the other hand, simply we say curly braces, open curly braces. All the codes until we meet end curly braces, they're all sub-code block. So more explicit indicator for the block for Java or Swift or C. But Python, indentation is important. About object, how we can indicate an object. Python, we call it self. Java, this and self. right? Only the language difference. The example that I put here comes from my textbook, but it's not required. Let's say if we have list, and I call here Python in that tuple, right? Tuple formats. It should be tuple format, right? Parentheses rather than square bracket. If it is a square bracket, then accurately speaking, all the elements in that square bracket should be the same type, same kind. But untyped and pound sign are not same kind. Pound sign and indentation are not same kind, right? They are all together constitute Python. Look here, they all together constitute Java. It's different languages, right? This, because this is a descriptor, if we drop any of this, then it may not be Python, right? What I'm saying here is that tuple as is, any element here cannot be modified. If it is a list, yes, we can. We can modify, we can drop any element, we can add more. But as far as tuple, literally, tuple is a sequence of a series of descriptors. So if you change the descriptors, then it doesn't point to that specific object anymore, right? Semantically, therefore, not allowed, which is good in cybersecurity. It's too early to say that, but yeah. But because of a tuple, sometimes you can manipulate the data in a secure way. If you want to share the data with others in tuple format, then the other guy cannot modify it, right? That type of things. But there is a way that you can modify it. In other words, this tuple itself can be converted to a list. If you want to convert this tuple to a list, then you need to say list and tuple variables. Then it can be changed to a list. Once it is in a list, then you can use the method that is available from that list. So dot append possible. Once you change anything of this, then you can convert it back to the original tuple formats. In order to do that, you need to do tuple, right? Tuple, list, those are, we don't call it function in object orientation, we call it constructor, okay? Looks similar because like a function name, open and close parentheses, this takes a parameter. Looks similar, but we call this a constructor. So Python tuple can be constructed in a list. This is a list, PYLST, because it is the outcome of this conversion. So this is a list. List can be converted back to tuple by calling tuple. We will practice that. So tuple does not have many methods. As I said, it's a series of descriptors. Main idea is not to modify it, right? We want to keep it. How can we maintain it as is? So not many methods developed. But there is a way that you can do if you have to do. You need to first change it to a list, and then you can play with all the features available in the list. And at the end, you have to convert it back to tuple. Then you will be okay, right? So only two methods, tuple, count, and index. So if you come here, this is the list. But if you say tuple, tuple math, see here, tuple, we have count and index. Only two, right? Count, text value, so returns a number of occurrences of that value. Fine. index returns first index of the value. If you want to say, I want to see the index of this specific value, then you can say index John. Then in that tuple list, it may tell you the position of that element John. Dictionary. Dictionary has also the method called update. So we can use this method update to update the dictionary. Dictionary should be updated, right? What that means is that we can add more items, more key and value pair, or we can update the definition of the given key. Because dictionary is a key and value pairs, if you want to get, there's a method. These are the good methods, so that we can take a look at that. Dict, then there's an update. Set default, pop item, pop keys, get, first of all get, then return the value for a key. If key is in the dictionary. Otherwise, if there is a default, then default can be given to you. Items, set of, like object, set of all the items can be returns. If you say keys, then set of keys. Set of keys. Set of all items, then items. Set of all keys, then keys. Values, then set of all the values. Somewhere here. Values, no values. Set of all the values. You can see this, right? Items, keys, and values. And so we looked at three major types, data types available in Python. Python has many more data types available. Those are not primitive, but anyway, they are so great and very, very useful in many cases. But we don't touch it from this basic level of codings. Among those three basic data types, there can be, so data type is like a container, right? So that container may contain another data types, which can in turn contain another data types. This is more like deeper levels and nested type of data constructed. If you see here, from here, this is a square bracket to the end, that's an ending square bracket. Entire is called a list. But if you see the elements, then this element itself is a tuple, right? Because first element is a tuple of two tuple elements, 131 and Python. If we say, I want a list of key and value pairs, I want a list of each course in a tuple. So course ID, CRN number, and course title in a tuple. 131 Python, 231 Java, 335 pen testing, 555 mobile tech, 585 advanced crypto, 570 mobile cryptos, for example. So this is called a list of tuples. The list can contain, list is a container which includes tuples. That's what it is. You can think a list of dictionaries, or you can say list of a dictionary of tuple, dictionary of a list. You have so many different combinations possible. Okay, so this is a list of dictionary. Then each element is in the form of dictionaries. Therefore, it has key and value pairs. Capital, Washington. Strength, finance. Capital Tokyo, strength science. Capital Berlin, strength engineering, for example, right? So we can say this is a list of dictionaries, as I said here. Each dictionary contains key and value pairs, but there are two keys, capital and strength. Similarly, we may think of a list of tuples that we looked at earlier, right? Or dictionary of key and value pair, but value itself is a list. We call it dictionary. Dictionary is a dictionary variable. This dictionary variable has key and value pairs. Mercy, there is a key. If you ask about Mercy, then I can give you the value associated with that key. The value here is a campus location, right? DF, MT, BX. NYU, then NYU, the key, then I can give you the location of the campus. NYC, Dubai, Shanghai. If you give me MIT as a key, then I can give you the location, Cambridge. All right, so this is the concept that we look at, and collab. Collab that I think I posted, right? So you can, this is IPYNB files. You can click to download your local drive, and then you can bring it back to your web browser and open up collab.research.google.com and upload it. So please do it now so that we can go together. That is a lab 2. So data types. I explained all, not all, but somewhere here, somewhere in the slide, sometimes in this lab. I wanted to read that. It's an example of a list. This is a list, right? Student is John, Adam, Chris, Brown. You can add more and more, right? You can add here, say, Bob. Manually, but you can use a method to add one more element, Peter, and print it so that you can see whether that is printed. So right now I want to and click to run. So if you want to see the list itself, then you need to put here student, right? That way you can see the list of students. John, Adam, Chris, Brown, Bob, that is given. And you want to append Peter. So Peter is appended. So up to this, that is counted. Next one, access an element of a list. Third element. So how can you do the third element? That's a student. And third element, therefore, that's index 2, right? Index starts from 2. So if you want to see it, then Chris. First, second, and third, Chris can come in. Second last element. Second last. Then you can count it from the beginning all the way to the last, second last. But if you want to see it, if you want to count from the last back end, then -2, which is the second last. So you can see that second last is Bob. If you want to keep this print, then you need to keep the print there so that it'll come always. So Chris first, and then this is the last ones. So without having to call that print function, you can print it as you can see there. But now I want to put the print. access multiple elements. So if you want to do, I want to see, for example, which ones can be printed. Angelica. If I say 2:4 from students, this is the students, right? 2:4. 2 is the third element, right? 0, 1, 2. So Chris comes.
It'll be from Chris to Bob.
Chris to Bob. This is the 2, 3. This is 4, number 4. Did I say 4 is included or excluded? In this range notation, beginning index, colon, ending index, then ending is, it counts all the way to the ending itself, ending index, but which is excluded. What that means is that then this is a second, this is number 2, this is number 3, next one is number 4, but number 4 is excluded. Therefore, we should have a Chris and Brown. Let's see what happens. Run it. It's a longer time. You guys might have quicker response. But here at Mercy University, from my office, takes forever. There is a warning. Saving failed since 12:23, a minute ago. Click. One more. Automatic saving failed. This file was updated remotely or in another tab. Okay. All right. So when I do this, it gives me a sublist. Adding a list to the list using extend. So if we do extend, I want to comment this out. And rather than this underline, if I say extend and run it, then it gives me, although I put there a list, it can be extended within that given list. Okay? But in other words, if I want to say print student append, and I say C, D, if I want to append that, automatic saving fails. Probably. Does it run slowly at your side as well? Or only it happens to me? Anthony, is it slow at your side?
No, it's fine for me.
Like here, okay. All right. So I have I did append. Why it doesn't? Okay. And then if I do okay. So this is C and D. Very similar to A and B here, right? Only difference here, extend and append. If we do extend, then each element can be appended. That is what extend, the definition of extend. Extend. Extend, list by appending element. Appending by appending element. By appending this element. So element can be appended, like append here, append Peter. This is an object that is appended, right? So if you do extend, then it should be written in a repeatable, so each element can be appended. Okay, append, then this entire can be treated as an object, so entire can be appended like this. What if we do append, for example, extend look here. So it says this itself is a repeatable. String is repeatable. String is a repeatable of what? Each character, right? So element in this repeatable is a character. So M can be appended, E appended, R appended, C appended, Y appended. Okay. If you do this append, then if you do append, then the parameter itself is an object. That object can be appended. Extend, then the parameter is treated as an iterable, so you can think, oh, what is an element in that string? Element in a string is a character, so each character can be appended. Next one is how many elements in the student list. Then here, by the way, your midterm exam is coming soon, right? I would say I will post it, but today is the last Tuesday of February. I would say 2 weeks from today. Or third week, which is the second week of March or third week of March. Third Tuesday or second Tuesday of March, 12th or 19th. I will decide that because we have a very small group. I do not want you to come, but one requirement, I want to continue to turn on your camera so that I can see you guys. So I'll be the proctor. I want to check your the midterm exams. So I'll be with you, but remotely, virtually, so we all can see the camera. What I'm trying to say here, the types of questions is like this. How many elements in the student list? Fill in the blanks. Then there's underlying blanks, but you need to say then students so that you can see the number of elements. How many elements? 1, 2, 3, 4, 5, 6, 7, 8. This whole thing is an object. 9, 10, 11, 12, 13, 14, 15. So 15 elements, right? One more thing that I want to do here. If we want to see, for example, from -4 to -2, from here, -4, -2 is the second last, right? So second last. So far student is, yeah, this is the students. This is -1, -2. Bob, Chris and Brown. -4 to -2. Oh, because -1. See what happens. Okay. Students. Student is appended, Peter. So student always to Peter. So -1 should be strange. So student -1. So what it is? Oh, right now we have here. Okay, so -2. Because of this. -2 is y. So for example, -4, -1, -2, -3, -4. So negative cases, if there's a positive, then this is a beginning and this is ending. Ending is exclusive. But if it's a negative, then it counts all. Because it doesn't count from somehow it works that way. No. Same thing. Yeah, same thing. Negative is not counted, right? Negative itself is not counted. We count -1, -2, -3, -4. So from here, -4, add one more, then -2, add one more, -1, -2, -3, -4. So -4, that is all. One more, then -3, one more, -2, but ending exclusive, right? So we have only, if it's a negative, then always confused. But anyway, that is. And we have, we looked at that. Okay. So homework there. So here, the way that you need to submit the homeworks. Some of you may be confused. Here's what I want. Let's say this is the code that you. Let's say this is your code, okay? The way that I ask you to do. So you highlight all this, and then you can copy it. And at the very beginning, you need to say, this is a homework problem 1.2, for example, okay? And this entire thing should be evaluated. Oops, I need to quit. Evaluated like this. Okay, so make sure that it is evaluated. Oh, it's not here. It should be somewhere here. And so you save this in your somewhere, for example, 505 class spring 24, and you can say homework 2. That is, the format of that is py. So .py, and come back your then there is a homework 2, right? So this homework 2 is very similar to, that is a homework 2. So plain text files, code itself. This should be, so this entire, that should be included in your submissions, okay? File itself needs to be submitted. That is the way that you can do homeworks. Tuple, this is tuple, very similar to the list. We can access the third one by index 2. Try other methods. So if you want to do append and extend, it's not going to work, right? Student Adam append nationality USA. I want to put another descriptor, but it's not, right? It says tuple object has no attribute append. Of course it is not. That's what I wanted to do. Yeah. How can you modify it? Then you need to change it to the list. Any possible way that you can do? You can do first Adam list equals list Adam, and then if you do print student Adam list, then you can see this is not anymore tuple but a list, so that you can use any methods available in the list that we looked at here, right? Any one of these can possible. There's a tuple. Dictionary in the curly braces, so that is the dictionary. If you want to access an element, then remember that list and tuple position is important. Therefore, you can access an element by index. But dictionary, position is not important. Key is important. Give me a key, I can give to you annotation, definitions. So key should be given. For example, what is the major? Then it gives me, because a major is a cybersecurity, it returns a cybersecurity. List one of the keys in the dictionaries. Oh, a list of the keys. List of the keys. How can we get the list of the keys? Then you need to do here. Student is a dictionary. That is a keys. Keys is a method. It gives us this. It says a dictionary keys, name, age, major, educations. If you want to give literally list itself, then you need to do list student. I'm sorry, it's not there. Put that here. Dot keys. Then it gives us, if you say student keys itself, then it gives me this. Literally, if you want to see list only, in other words, this only internal this, then you need to say list. This is a constructor of the list. So it gives me this. List of the values. Then you need to say here, student and values. Open and close parentheses. So that is a method, that is a function. Therefore, you can see here value only. John, 29, cybersecurity, multi universities, right? Value only. Pretty list of the values. What do you mean by that? The literally values are, values themselves in a list. Then you need to do list. Print. Then you can see the values only in a list. Update. There are two ways that you can update. Number one is to use update function or using a key. So if you want to do updates by adding, for example, major age. So I want to update the age. Currently 29, but 30 turns 30, so that we can see. So 30 here, right? It is updated. The update, the primary itself is a dictionary format. It's not like update to 30. We do not know what 30 is, right? It should say 30 for the key age. So they should be in this form. We can do that using key value, the key itself. So if we want to do, for example, John age major education. I want to change education. Change education to, say, MIT. Then it can be changed to MIT. Okay. Similarly here, if we want to do, oops, where is it? Okay, here, Python. I want to update the key skill with the value Python. What would happen in this case? We know that if it is ag, then ag can be updated to 30. There's a key not available. There's no skill. If it is the case, for a moment, if we do that, then if there is a key, then we can update the value. If there is no keys available, then add that. So skill is added. Okay. Similarly, therefore, so MIT is there, right? Now, if we do hobby hiking, then it can be added because hobby is not the key available there. Therefore, hobby is newly added and value as well with it. Extension. As I said, these three basic data types can be, one can contain another, which can contain another and another. So depth of that data types be great, deeper levels, right? A few of those examples is department of dictionary in a list of department information. So this is a list. Our container is a list. Each element is a dictionary. Name Cyber, Chair Chris. Name CS, Chair David. Dictionary values can be a list. So in this dictionary, see here there's curly braces. Value for Adam is a 99, 78, 87. Bob, the value is a list. So it could be a transcript. Another could be a dictionary contains another dictionary. So dictionary values will be another dictionary. Adam is a key. Value for Adam is a dictionary. So Adam's homework is this. Adam's exam, this. This whole thing is about Adam's. Bob's homework, this. Bob's exam, the other. And so on and so forth, right? Let's say we have students, many students in dictionary formats. We can collect all of those dictionaries in a list. Then you need to say, in a list, student 1, student 2, student 3. Then this student JSON is a list. Each element is a dictionary, as you can see here. So there is a homework assignments also. Okay. How can you access, for example, here, not this, JSON here. How can you access first dictionary? Then you need to say here, first dictionary is, because JSON, this student JSON is a list. First element is a dictionary. First element in a list can be accessed by an index 0. So you can have, that's the first element, right? If you want to see what is his age, what is the first student, what is the age of the first students, then you need to do here JSON, student JSON, first element, and then you can say what is it, age, then 29. So that age can be accessed. So each one of these can be accessed anyway, right? Although that is a very, very complicated formats like this. Very, very complicated. Imagine you can pinpoint any specific value to obtain. So lots of things, right? So I give you quick lecture and lab. So so practice this and watch and follow step by step using your core lab notebook. When you complete your homework assignments, then you can take that code itself in a file, so that the way that I can evaluate is to execute your files to see it gives me the result. Okay, that's what I want to say. Any questions? Any questions from anyone? If not, I think this is all that I want to say to you. This is pretty big amount of the skills that you can learn, and therefore you may be ready to handle these things for real the processing, computing, conditional statements and iterations, and define functions and invoking the functions. All those things will be learned step by step.